Okay, so in this part, we want to understand how you determine if a circuit is valid or invalid. Well, for you to do that, a circuit just has to satisfy the basic principles. What are these basic principles? Well, there are quite a number of them. Among them, the most obvious, we have KCL, Kirchhoff's current law. The current entering a junction has to be equals to zero. The sum of current entering the junction at a junction has to be equals to zero. KVL, the sum of the voltages around a closed loop has to be equals to zero. So apart from this, you also have basically power supplied in a circuit. I think we have discussed all that. The power supplied in a circuit has to be equal to the power absorbed in a circuit. So these are just some of the concepts that must be satisfied if a connection has to be valid. Now, there are a few things that that you need to keep in mind, and the questions that we have here are going to be enough to elaborate everything that you need. So let's start with the first one. So these questions are quite basic, and I hope they'll help you guys just get a picture of how we actually end up concluding that an interconnection is valid or it is invalid. Look at the first one here. Does it disobey any of our known laws? Well, here's what you want to look out for. You have a circuit element here. Now, the circuit element here can receive any voltage, depending on what we're feeding it, of course. Now, does the current here, we're saying the current here is different to the current the other side, but does it really affect what is happening here? Well, it actually doesn't affect what is happening here. Why do I say so? You see, the current sources here, they may have whatever voltage necessary here and here. So they will just receive whatever voltage is necessary. And in return, they will produce their own current. Now, even though this is producing a 1 amp current and this is producing a 2 amp current, the concept here is that the potential difference between them, across this point and also across this point, will still be the same, regardless of what current value they are supplying. So for this circuit, we conclude that this circuit is actually valid, even though we have the different current values there. They won't break any of our known concepts. So all that we expect to see here is for it to also satisfy Kirchhoff's current law, we know to say the current entering a junction has to be equal to the current leaving. So if 1 amp enters, and here we're seeing 2 amps is leaving, what does that suggest? Since the current entering has to be equal to the current leaving, it only suggests that, well, here we must have a 1 amp also entering, so that when we add this current and this current, we get a 2, which must be that 2 that left using that other branch. So this is valid. Let's look at the next one. Look at this one here. Is this valid or not? Well, here we're seeing a voltage, another voltage source connected in parallel, and then they're also connected in parallel to a 1 ohm resistor. Unlike the 2 current sources there, this is actually not valid. This is not valid. Why? Well, across the 1 ohm resistor, according to the left part, you see, this is supplying a 1 volt source. If I gave you something like a circuit like this, and then here you have plus, minus, and then here you have a resistor, 1 ohm, just this, and then let's say this is a 1 volt supply. What you see is that by, you can even use KVL here, what you notice is that you can actually conclude that for this circuit, the voltage drop, since the sum of the voltages around a closed loop, according to Kirchhoff's voltage law, has to be equals to 0, we conclude that the voltage here has to be equal to the voltage here, because when looping, we're going to have minus 1 volt, then here we're going to have plus the voltage here, and then so this is the voltage across the 1 ohm. This has to be equals to 0. We conclude that V is equals to 1. So if you look at this circuit, When you use Kirchhoff's voltage law here, first let's label the voltage across that 1 ohm to be V. Polarity, we can set this to be plus minus because it connects to the positive of either terminals there. So look at how this is going to go. If you use Kirchhoff's voltage law this side, what do you see? Well, you have minus 1 volt this side, but here you have plus the voltage across that 1 ohm. This is equals to 0. You get V is equals to 1 volt. But look at what happens when you do the same thing but the other side. When you do the same thing the other side, you find minus our V down here, minus V. And when you continue, you find the 2 volt here plus 2 volts equals to 0. Notice that from the second loop here, we conclude that V is equals to 2. Well, this is not right. Since it's the same element, the values must be the same. One side we're finding 1 volt, the other side we're finding 2 volts. So it implies that this circuit is actually invalid. That's one way you can look at it. You can also look at this circuit. Instead of taking 2 loops like this, you can just consider the outer loop. Remember, Kirchhoff's voltage law says the sum of the voltages about a closed loop doesn't necessarily restrict us to just these loops. Instead, it also allows us to take this loop, the outer loop there. So if we do take the outer loop, what do we see? So from the outer loop, what we see is that the first one we find, if we start from down here, the first one we find is the 1 volt minus first. And when we continue, we find the 2 volts plus first. And those are the only 2 elements in this loop. Is this supposed to, and this is supposed to be equals to 0 according to Kirchhoff's voltage law. But clearly this is not equals to 0. Because of that, this circuit is not valid again. So we could have concluded that it is not valid from either. When you look at the circuit at C here, is the circuit valid or it is not valid? Well, this one is actually invalid. It is not valid. Why? Because when you look at this current source, when you have a current source in a branch, that current source actually tells you the current in that branch. So if you have a 1 amp supply here, it tells you to say that along this line, all you have is a 1 amp current flowing. So this current source is suggesting that you have 1 amp flowing. But look at the second one here. It is suggesting that you have 2 amps flowing in the same line. So we cannot have this. It's either it's 1 amp only or it's 2 amps only. We cannot have 2 current sources giving us 2 different values in the same line. We can't have that. So this circuit is not valid. So it is invalid. So we move on to the next one. So we have D. Well, unlike current sources here, for this circuit here, when you have voltage sources, it's actually okay. The 2 voltage sources can have their own voltage values. So they are literally just going to supply the voltage and they're going to tell us the voltage here and the voltage here, and that is the voltage that this is going to see. In other words, if this is supplying, this is also supplying its own value. In the end, their contribution is what this resistor is going to see. So unlike current sources here, where they are telling us different current values in the same line, voltage sources can be placed in our circuit and they don't really do anything. They don't really mess up our circuit. So the voltage sources may have whatever current that is necessary. So whatever current is necessary here will flow. Doesn't matter whether this is a 1 volt or that is a 2 volt. So they and that 1 ohm resistor, they'll all carry the same current. So even though they have different values here, the current that will be passing through these voltage sources will be the same, even though they have different voltage values. So because of that, this connection is valid. Lastly, we have this one. Here we have a current source and here we have a voltage source. Again, this connection is, we're going to conclude that this is actually valid. So even though we have this current source, it just tells us how much current is flowing in our circuit. So it doesn't really break any of our known concepts. So the 1 volt can actually can accept any current to flow here. So this is actually okay. And when you look at this, even just check through the orientation here, the direction of the current here, and even the polarity of this battery. It actually indicates that current here is flowing in this orientation, which is actually in the same line as what that current source is telling us. So we are actually okay here. So this is how you conclude whether an interconnection is valid or invalid. Next up, let's look at the power check.